Hey guys, this is Andre here, and today I'm very excited to announce that I'm going to be starting a new series. It's going to be a competitive programming series where I will kind of go through a bunch of different competitive programming problems from HackerRank, starting from like easy to like the hard ones. And I kind of want to show how I think about them, how I solve them. I've never actually solved any HackerRank problems before, so they're new to me as well, so that'll be exciting. And yeah, we will get to experience them together, and you can see how a experienced software developer kind of thinks about these things, and hopefully you can learn a lot from this. Um, yeah, let me pull up HackerRank here. I have the first problem. It's called Find the Point. I think it's the first one HackerRank offers you. It's a pretty simple problem. Uh, Basically, you have 2 points, point P and Q, and they have an X and Y coordinate. And you need to find a point of reflection, point R, which is the point that shows P being reflected across Q 180 degrees, so really rotated 180 degrees. So the way that competitive programming problems kind of work is usually they'll give you in the input, they'll give you a number that will define the number of test cases that there's going to be. So you read that number and then you kind of loop through that. And then every line is going to be the input to the function that you're trying to solve. And then you kind of output the result. A lot of times with this like mathematical problems, it's very useful to kind of draw an image or a picture so you can visualize it. I always say if you can visualize it, you can understand it, you can definitely solve it. In this case, they have a really good picture for us, and they give us the code. I will be using C++ 20, but we can do it in Python or some other language if you want. I'll kind of do it in VS Code, and then we'll do it in HackerRank as well. VS Code is great. It's a free IDE. I think it's the best one. There's so many extensions you can attach to them. And by the way, I'm not sponsored by them or anything. It's just that's what I personally use, so I recommend it. You can even install, in this case, a compiler and the runtime for C++. So I think it's good. But let's get back to the problem. So here we see we have point Q at 2, 2 in this Cartesian plane, and point P at 0, 0. So we're trying to find R, right? Which they have provided for us here, but we're basically rotating 180 degrees, which means we're doing a reflection over the x-axis and over the y-axis. We're inverting the points. And since it's a linear transformation, we're not doing any scaling or stretching. We would expect the distance between the 2 points to actually still be the same, because that's what linear transformations do. We can find the distance between the 2 points, right, using Pythagorean theorem. It's just Euclidean distance in 2 dimensions. And it would be, the distance would be the square root of a squared plus b squared, which in this case would be 2 squared plus 2 squared, which is 8, which is 2 root 2. So that would be the distance, and it's just, the diagonal on these 2 squares. And then, as we can see, it's the same on the r. So yeah, I think it's easy to see. Point P is 2 units below point Q and 2 units to the left. So when we flip everything, it's 2 units. Point R is 2 units above and 2 units to the right. If point P were here, 2 units below and 2 units to the right, point R would be here, 2 units above and 2 units to the left. So how do we have the solution? They give us the points, for instance, 0, 0. So P will always be first. It says here, Px, Py, and then Qx, Qy, the y components. And then 1, 1, or in this case, it would be 0, 0, and 2, 2. So how do we find the answer? So let's start looking at the code. They give us this function, find point, that we're going to be implementing. And what I have done here is I have kind of sample code. You should always have like a base file with this kind of sample code, because then it's very easy to, especially if you're going to competitions for competitive programming, there's no solutions here, and this is actually allowed in competitive programming, and it's just set up to read input and print your output. So you don't have to do that every time. You can just copy and paste your output. And I'll explain it very briefly. I can do a video and explain it in more detail if you guys want, but basically we read a line of input, turn that into an int. So that will be the first number that shows the number of test cases. Then we loop. I'm looping in reverse, but it doesn't matter. In C, you need to return 0 for status success. And then for each test case, we read a line, the next line of input from standard in. And what I'm doing is I'm using a iString stream to split the words on the space character and just push it into a vector, which if you're not familiar with C++ vectors, they're just lists of strings. And then I just print my output. In this case though, output is not going to be a vector of string, it's going to be a vector of integer. And it's just going to be the result of my find point function, which is going to have px, py, qx, and qy. And then we don't have those values defined, so we're going to say integer px is going to be string to integer input 0. So our input is going to look like this, 0, 0, 1, 1, and in this case, test cases, right, would be something like this, or 1 if we just have one line of input. Okay, so then our qy would be, so each of these is going to be stored at an index in input. So our py would be the next value, our qx would be the value after that, and our qy would be the last value. So indexes 0 through 3. So we save this. So let's actually solve this answer. So we're going to define a vector of integers, result, and then of course we need to return result at the end. And we need to find the x and the y components of Rx. So integer Rx is equal to, and what we said was, in order to solve this, we would find, for instance, the difference in the x component, right? If we go 2 units to the left, we know we need to go 2 units to the right. So how do we find this? Well, mathematically, we find the difference in the x component. So in this case, our x component is 2, our x component is 0, the difference is 2, of q minus p is 2, and then we add it to our current value, which is also 2, and that's how we get 4. Now, if r were here, and p were here, the difference would be q minus p, it would be 2 minus 4, which is negative 2, and we add it to our cube component, which is 2, and it gives us 0. And then, so that's what we're going to do. So qx minus px plus qx. And then integer ry is equal to, it's actually going to be the same thing, but in the y component, right? And I'll show that briefly. Our y component is 2, our y component is 0, 2 minus 0, 2, and we add 2 plus 2, 4. And then if it's flipped, it would be 4 minus 2, negative 2 plus 2, 0. If it's, well, in this case, if r is here, it would be 4 minus 2, which would be 2, and then plus 2 will be 4. So that would work as well. If r was here, then it would be 4 minus 2, negative 2, plus 2, 0, and then that would also work. So we kind of checked all the different cases. So now we're just going to push it back. This is how you add an item to a list. And then we just return that, and we can kind of test it. I'm building it, compiling it in C++. It's going to open up a new terminal, and let's see, we want to input 0, 0, 1, 1, the result would be 2, 2, 0, 0, like 3, 3, the result would be 6, 6. All right, so this is good. So we can just copy this into HackerRank. We can put it in the function here. Now, if I were actually solving this at a competitive programming problem, I would probably not even define this because it's a waste. And then I'll just do this, and let's see, let's run a code. This should work. So hopefully this was, I did a lot more setup and the submit and do all the test cases, but hopefully this was useful and you liked it. And it was interesting, and it kind of helped you see. Next time we'll be solving more challenging and more interesting problems, so stay tuned for more, and let me know what you want to see next. Thanks a lot, guys, and have a great one.